Topic: Mechanics, Vectors and Scalars. Aims of lesson: to introduce the concepts of vectors and scalars. To classify physical quantities as vectors or scalars. To learn and remember the properties of vectors. Introduction. We are now starting with mechanics, and mechanics is the section of physics that deals with the study of motion, kinematics, and the forces that cause motion, dynamics. Many of us rely on transport to get to school each day, and we use many different machines to perform many tasks. For us, when we study mechanics, we will focus on the interactions between matter and the forces on it. We use these principles to design machines, cars, taxis and buses, and even to understand how the Earth orbits the Sun. It is important, therefore, to have knowledge of physical quantities because technology is constantly improving. A physical quantity is a measurable property of something that we find in nature. If we measure something and the changes it undergoes, we understand more about it. Physical quantities are divided into scalar quantities or vector quantities. Concepts and skills. Part 1. Scalar quantities. Scalars are physical quantities that have magnitude, size, only, and no direction. Examples: quantity symbol SI unit. Time T. Seconds S. Mass M. Kilogram kg. Temperature T. Degrees Celsius C. Distance D. Meter M. Speed V. Meter per second ms1. Vector quantities. Vectors are physical quantities that have both magnitude, size, and direction. Examples: quantity symbol SI unit. Force F. Newton N. Weight Fg or W. Newton N. Displacement delta x or delta y. Meter m. Velocity v. Meter per second ms1. Acceleration a. Meter per second squared ms2. Complete activity 1 in your notebook. Part 2. How to draw vectors, the graphical representation of vectors. The magnitude and direction of vector quantities can be represented by means of a vector diagram and arrow. The length of the arrow indicates the magnitude, size of the quantity, and the arrowhead indicates the direction of the quantity. Magnitude. Can you identify quantities as scalars or vectors? Draw vectors. For example, you cannot draw 100 kilometers on your page, and therefore you use a scale to make it smaller so that you can draw it on your page. Examples. Use a scale of 10 mm equals 10 m in order to draw 1. 50 m south. 2. 75 m east. Solutions. 1. 50 m equals 50 mm. 2. 75 m equals 75 mm. Complete activity 2 in your notebook. Part 3. Properties of vectors. 1. Two vectors are equal if they have the same magnitude and the same direction. For example, 100 n west equals 100 n west. 2. Positive vectors point in a positive direction and negative vectors point in the opposite direction, for example, north and south. If you choose north as the positive direction, then south will be the negative direction. 3. We add vectors in a straight line using the sign conventions, for example, right is positive and left is negative, or north is positive and south is negative, but never combine right and north, etc. Part 4. Differentiate between scalar and vector quantities. Scalar quantities can be added and subtracted just like ordinary numbers. If we place 3 apples in a bowl and then add 3 more apples, there will be 5 apples in the bowl. However, when we add vectors, the direction of each vector makes a difference. If 2 people push on a door in the same direction, the effect is not the same as if they push in opposite directions. With vectors, we must consider their direction. Examples. Scalar quantities. Vector quantities. Adding scalars. Only the sum is determined, direction is not considered. A. 10 kilograms plus 15 kilograms equals 25 kilograms. The mass of 2 children is 25 kilograms. B. 2 kilometers plus 2 kilometers plus 1 kilometer equals 5 kilometers. This is the total distance walked by a girl from home to school. Adding vectors. Directions of vectors must be considered. A. 3m east plus 2m west equals 1m east plus 3m plus minus 2m equals plus 1m. The 2m west is in the opposite direction, that is why it is subtracted. B. 3m east plus 2m east equals 5m east. The distances are in the same direction, so it is added. Activities / Assessment. Activity 1. Copy the table into your notebook and complete it. No. Quantity vector or scalar magnitude direction. 1.1. 36 degrees Celsius, C. 1.2. 23 centimeters. 1.3. 60 kilometers per hour, km/h 1. 1.4. 60 km/h 1, south. 1.5. 250 grams, g. 1.6. Running 5 steps forward. 1.7. Your weight of 550 N. Activity 2. In this practical activity you will draw to scale a 400 N force that acts upwards. Instructions. 1. Indicate the reference direction, small arrow up. 2. Decide on a suitable scale, for example, 1 mm, 10 N. 3. Draw the vector to scale in the correct direction. Its length is 40 mm for a scale of 1 mm, 10 N. 4. Write the scale on the drawing. 5. Show the direction of the vector with an arrowhead. 6. Label the vector to identify it, give its magnitude, size, and direction. Consolidation. You can now identify physical quantities as scalar or vectors quantities. You should be able to draw vectors by using a scale, using the length of the arrow to indicate the magnitude, size, and the arrowhead to indicate the direction of the quantity. You must be able to add vectors acting in the same direction and in opposite directions. Good luck with the lesson. Values. Attentiveness and independence are the values specific for the lesson. You must follow the rules and learn to work on your own. Thanks for watching. Please do not forget to like, share and most important subscribe to the channel.